Problem 10b wants us to graph the curve, set up the chart and plot the points, label the orientation, and eliminate the parameter, and write the equation in rectangular form. So in order to graph this, I need to set up the table to get my points. So I'm going to do a table of t, x, and y. These here, sine of t, that's not really sine of theta, that's sine at time t. So t is my theta value, but I just don't want you to get confused. We're not looking at an angle, we're looking at plugging in a time value. So my t's, I'm going to go with 0, pi over 2, pi, 3 pi over 2, and 2 pi. If I need some clarity, I can add a few more data points, like pi over 4, 3 pi over 4, 5 pi over 4, if I'm really not sure what my graph is supposed to look like. So if I do sine of 0 for x is going to be 0. Cosine of 0 is going to be 1, and I still have to multiply that by my 5, which is in here. I forgot to write that down. So this is going to be 5. Pi over 2, sine of pi over 2 is 1. 1 times 5 is 5. And cosine of pi over 2 is 0. 0 times 5 is 0. Sine of pi is 0. 5 times 0 is 0. Cosine of pi is negative 1. Negative 1 times 5 is negative 5. And then if I go to 3 pi over 2, sine of 3 pi over 2 is negative 1. Negative 1 times 5 is negative 5. Cosine of 3 pi over 2 is 0. 5 times 0 is 0. 2 pi is coterminal to 0, so we're right back where we started here. So the next thing I want to do is add my graph. So then I can start plotting my points. 0, 5, 5, 0. Notice I'm plotting my x and y's. I'm not plotting my t's. 0, negative 5, and negative 5, 0 gives us this graph here, which makes a Bob Ross happy circle. So now that we have our graph, we know that we're going to be graphing a circle, and we need to put it into circle form. And what we remember from our conics unit is that circles follow the equation x squared plus y squared equals r squared. So that can kind of help us navigate through how to eliminate the parameter and write the equation in rectangular form. So on this particular one, I tried to get t alone, and all I was able to do was say x over 5 equals t, because I can't undo that sign. Actually, that's better. X over 5 equals the sine of t. The only way that I'd be able to undo sine is do the arc sine, and I don't really know how to do arc sine of x over 5 when x is a variable. So that's about as far as I can take that. I'm going to do the same thing with the y equation. So I know that y over 5 equals cosine t. Then I can also use Pythagorean identity. Now that I have these, I can use the Pythagorean identity of sine squared t plus cosine squared t equals 1. So then if I just take this guy here and square it, and this guy here and square that, then I've got a sine squared t, and a cosine squared t, and I can plug those in. So x squared over 25 subbed in for sine t, and y squared over 25 subbed in for cosine t equals 1. I can leave it in that form, or if I really wanted to make it pretty, I can say x squared plus y squared equals 25. So that gives me my x squared plus y squared equals r squared equation for a circle like I would expect. So I would take either one of these answers.